In order to solve cubic equations, just like quadratic equations, we need to have the equations in factor form first. And then once we've got them in factor form, then we can let each of the factors equal 0 and solve them separately. Now, in this first one, you can see that we already have got factor form. So therefore, it's just a simple matter of letting each of those factors equal 0. So x minus 2 is equal to 0, so x equals 2. X plus 1 is equal to 0, so x is equal to minus 1. And x plus 3 is equal to 0, so x equals minus 3. So that is now completely solved. The next question, x cubed minus 4x squared minus 11x plus 30 equals 0, is not factorised. So we have to get it factorised. This has a lot of work involved because we have to go right back to the beginning and find a factor and use long division first so that we can factorise the whole expression and then solve it. So we go through our process of trying to find different values here that will give us a remainder of 0. And just to cut the process a little bit short, I'm going to tell you that p of 2 will do that because you get 2 cubed minus 4 times 2 squared minus 11 times 2 plus 30. Okay, and so when you put that into your calculator, 8 minus 16 minus 22 plus 30 is equal to 0. Therefore, x minus 2 is a factor. That's our first factor. All right, we need to use long division now to get, our other factors out. So we have x minus 2, and it's going into that whole expression, which was x cubed minus 4x squared minus 11x plus 30. We ask ourselves, how many times does x go into x cubed? The answer is x squared. So x squared times x is x cubed. X squared times minus 2 is minus 2x squared. Subtract. Okay, we've done this process before. Minus 4 plus 2 is minus 2x squared. Bring down the 11 and start the process again. How many times does x go into minus 2x squared? The answer is minus 2x. So minus 2x squared minus 2x times minus 2 is plus 4x. Subtract. Those two should cancel. Minus 11 minus 4 is minus 15x. Bring down the 30. And the last step, how many times does x go into minus 15x? The answer is minus 15. And so minus 15x minus 15 times minus 2 is plus 30. And remember, we should end up with 0 because we found that x minus 2 was a factor. So therefore, our factors for this are x minus 2, x squared minus 2x minus 15. Now that second one's not a linear factor, but of course, if I use cross bridge there, factors of minus 15, which give you negative 2, would be minus 5 and 3, and minus 5 plus 3 is minus 2. So our linear factors, x minus 2, x minus 5, x plus 3. And remember, we're wanting this now to equal 0 because we're solving. Okay, we're solving. So when we solve this, we've got our factors again. So x minus 2 equal to 0, x equals to 2. X minus 5 equal to 0, so x is equal to 5. And x plus 3 equal to 0, so x is equal to minus 3. They are our 3 solutions there. A lot of work. So we had to factorise using long division. And before we could even do long division, we had to find a factor. So a lot of work involved in that one. Okay, a couple more examples, and of course we've got to inspect all of these to see what's going to be the quickest way. I mean, we can always do long division, but that's going to be the longest way. If we can take out a common factor first, that should be our first step always. So in this one here, there is a common factor, so I'm going to take out x, and I'm left with 2x squared minus x minus 1 is equal to 0. Now, that's a quadratic, and if we can factorise that quadratic easily, we should. Go back and look at your factorisation for quadratics if you don't know how to do this. But we can either use the decomposition method or just a quick cross-bridge method. So if I use cross-bridge here, it's 2x and x, and my factors would be 1 and minus 1, because remember we go that way. So my factors are x, 2x plus 1, x minus 1 equal to 0. And so now that it's fully factorised, I can let each of those factors equal 0. So my factors would be x equal to 0. Let 2x plus 1 equal 0. So you get x is equal to minus 1 half. Let x minus 1 equal 0. So you get x is equal to 1. That is the absolute minimum amount of working out that I'd like to see for a question like that. All right, looking at the next one over here. Again, you should be able to see that x is a common factor here. So let's take that out. And so we get x outside of x squared plus 2x minus 10 is equal to 0. That equal to 0 is a giveaway that we have to find the values of x in the end, not just factorise. Okay, so can we factorise that quadratic? Well, the answer to that question is not simply, because there are no factors of negative 10 which add up to 2, but that means now that we have to complete the square. So let's keep x outside, and we will now complete the square on this. So x squared plus 2x, half of 2 is 1, squared is 1, take away 10. All right, and if you like, we'll put a big square bracket around that, and then a little bracket. So all I'm doing is completing the square on the quadratic there. So the x will stay outside as per usual, all right, and the bit inside, so this becomes inside, that becomes x plus 1 all squared. Again, go back and have a look at completing the square if this is not familiar to you, minus 11. And so I need to make that bit inside the difference of 2 squares. So x stays outside, and I've got x plus 1 all squared minus the square root of 11 squared, because I need to have 2 squares. Well, overall now, what does that become? It becomes x plus 1 plus root 11, x plus 1 minus root 11. And of course, it was all equal to 0, so I'm letting it equal to 0. And now I can let each one of those equal 0 and solve. So my first one, letting x equal 0, that's my first solution. Letting this one here equal to 0, I have to bring the 1 across, so it's minus 1 minus root 11. All right, and for this one here, the last one, all right, bring the 1 across, it becomes minus 1, bring the root 11 across, and it becomes plus root 11. And they are my 3 solutions. Now the hint for the next two says use grouping. We've done grouping 2 and 2 when we did the decomposition method. But let's go back through this to remind you of what that looks like. Sometimes you can group the first 2 terms and the last 2 terms together. Sometimes we have to reorganise it so that we can use grouping 2 and 2. But in this case, I'm going to group the first 2 terms together, which is those 2, and I'm going to group the last 2 terms together. So if I group the first 2 terms together, I'm going to take out a common factor there. And the common factor is x squared. Left inside my bracket would be x, because x squared times x is x cubed, minus 4. Now really what I want over here is for this bracket to be x minus 4 as well. Can I take out a common factor which gives me that bracket? And the answer is yes, I can take out minus 11. And remember, all of this is equal to 0. Now, what we do is take out the bracket as our common factor there, so that's x minus 4, and we put the bits that are outside in one bracket, so that becomes x squared minus 11 is equal to 0. That's now in factor form. So x minus 4 equal to 0, so x is equal to 4, and x squared minus 11 equal to 0, x squared equals 11, so x is equal to plus or minus the square root of 11. And they are my three solutions. Remember, x equals 4 is 1, x equals positive root 11, and x equals minus root 11. All right, and we're going to look here at our last question. Can we do this one the same way? Well, let's try. Let's try group the first two together and the last two. Again, we're looking for a bracket that has to be the same, otherwise it won't work. So taking out x squared here, and I'm left with x minus a. So that bracket that needs to be the same is x minus a over this side. Can we do that? And the answer, fortunately, is yes. Minus 11 outside of x minus a, and of course, again, that all equals 0. Take out your common factor, which is that bracket, and everything else that's outside those brackets goes into one bracket. All right, and now we let each of our factors, because that's fully factorised, we let each of our brackets equal to 0, and you get x minus a equals 0, x equals a, and the other bit there, x squared minus 11 equal to 0, x squared equal to 11, and x is equal to plus or minus root 11. Again, that has three solutions. Now that doesn't always work. Sometimes you do have to do long division like we did in one of the previous examples, but if you can find shortcuts to make your life easier, then you should be trying to do that.